to solve this equation for x, we have to get rid of the absolute values. One way to do it is just to, let's say, ignore them. So we have 1/2 x plus 5 is equal to 10. This is saying that, well, the thing inside the absolute value, it's just like putting a 10 there. It would have to make the equation true because the absolute value of 10 is 10. So that's like saying make the thing inside equal 10. But you can also take 1/2 x plus 5 and let that equal -10. If you put -10 into the absolute value, it would have to give you a solution as well. So here we have two equations, and we're going to get two different solutions. Solving both of these will be pretty similar. I'll have to subtract 5 from both sides in both equations. In this first one, I get 1/2 x is equal to 5. And in the other one, we get 1/2 x is equal to -15. And finally, to get x by itself, we can multiply both sides by 2. We have x is equal to 10, and also x is equal to -30. So that's two separate x values. X equaling -30, this is the one that would give me -10 inside absolute value. X equals 10 is the number that gives you 10 back inside absolute value as well. So I actually want to check this. So I'm going to check my work. Is 10 in fact a solution? If I put 10 in place of x and simplify it, does it make the left side equal the right side? And it should. Half of 10 is 5, and 5 plus 5 is 10, and the absolute value of 10 is equal to 10. So that works. For -30, okay, let's see. We have the absolute value of 1/2 of -30 plus 5. Is that equal to 10 in absolute value? Half of -30 is -15. And -15 plus 5, well, that gives me -10. But in this case, the absolute value of -10 is +10. So 10 is equal to 10. So these are the two solutions to this absolute value equation. So here we have a slightly more challenging absolute value equation. The only difference here is there is a +1 outside of the absolute value. To deal with this, what we're going to do is solve for the absolute value of 2x plus 3 by moving that -1 to the other side. So we're going to subtract 1 from both sides of this equation. If we do that, we get the absolute value of 2x plus 3 is equal to 7. This is a necessary step. You can't just ignore the absolute value symbols first. You have to solve for the absolute value piece by itself. Once we write it this way, now you can break it up into two pieces by asking, well, where's the absolute value of 2x plus 3 equal to 7? But also, where's the absolute value of 2x plus 3 equal to -7? Solving these will be very similar. We'll subtract 3 from both sides in both. We're left with 2x is equal to 4. But over here we have 2x is equal to -10. Now if we divide both sides by 2, in both equations, we get that x is equal to 2, but x is also equal to -5. So you can check that both of these are solutions to the equation, which isn't a bad thing to do. You plug 2 in place of x, -5 in place of x, and just be careful to follow order of operation when showing the left side is equal to the right side. In this example, we have two absolute value expressions equaling each other, so this one's a little bit different. But let's take the same approach. What we're going to do is just ignore the absolute values. So we have 2x plus 7 is equal to 1 minus 3x. If those two things are equal, like, I don't know, if they both equaled 5, well, if you took the absolute value of those two things, they would have to be equal as well. So if you want to see what another equation would be that would give you a second solution, here's one, where 2x plus 7 is equal to the negative of the other side. In this equation, you're saying, well, I'm taking the absolute value of one number, but if you take the absolute value of its negative, they're going to balance to be the same thing. And so I used 5 as an example, but what I mean is the absolute value of 5 is equal to 5, so that's like my first equation where I'm just setting the two things equal to each other. And in the second one, I'm saying, well, the absolute value of 5 could be equal to the absolute value of negative 5, where I'm taking one equation and leaving it alone, and I'm making the second equation the negative of what we start with. So let's solve these. I think on the left, I'll start by, maybe I'll add 3x to both sides. So I have 5x plus 7 is equal to 1. I'll now subtract 7. So I have 5x is equal to negative 6. And I'll divide both sides by 5. So we get x is equal to negative 6/5. Okay, that's one number. Now if I look to my second equation, I want to just be a little bit more careful this time. I'm going to distribute this negative into the parentheses, and I see that this is going to change things quite a bit. So I have 2x plus 7 is equal to negative 1, but now it's going to be plus 3x. So if I want to solve this equation, maybe I'll take the approach of subtracting 2x from both sides as my first step. I'm left with 7 is equal to negative 1 plus x. And now if I add 1 to both sides, I get that 8 is equal to x. So these are the two solutions to my original equation. The idea is if you have the absolute value of something equaling the absolute value of a different expression, there's really only two equations that you need to check. Set them both equal to each other, but then make one the negative of the other and see what solution that gives you.